Okay, let's take a look at number 10. The function f is differentiable for all real numbers. The point 3 comma 1/4 is on the graph of y equals f of x, and the slope at each point xy on the graph is given by dy dx is equal to y squared times 6 minus 2x. So we want to write the equation of the line tangent to f at the point 3 1/4. So again, whenever we are writing a line tangent or tangent line, I need a point, which we're already given both the x and y coordinates, and I need a slope. Slope is just, again, dy dx at the point 3 comma 1/4. So that's going to be 1/4 squared times 6 minus 2 times 3. 2 times 3 is 6. From 6 gives me 0. 0 times anything is just going to be 0. So I get a slope of 0. Now we can jump right in at this point. We know it's horizontal. Therefore, I know the equation is just going to be y equals whatever the y coordinate is. If that isn't where you're at, then just jump right into y minus y1 equals the slope times x minus x1. Y minus 1/4 is 0 times anything is 0. Add the 1/4 and we're still going to get y equals 1/4. Remember that dy dx, we're going to come back to it, is 0 at the point 3 1/4. So I want the second derivative of y. So just for reference sake, I'm going to go ahead and write that dy dx is equal to y squared times 6 minus 2x. Okay. So let's go ahead and find that second derivative. So let's derive both sides. I get d squared y over dx squared equals, this is a product, so we'll take the derivative of the first, so that's going to be 2y dy dx, chain rule, times the other, so 6 minus 2x, plus the derivative of the right side, that's negative 2, times the left side. All right, now again, we could go ahead and take this whole entire expression for dy dx, y squared times 6 minus 2x, drop it in for dy dx to get an actual expression in terms of x and y. I don't think we necessarily need to. I'm just going to go ahead and write it. Sorry, dy dx is equal to y squared times 6 minus 2x. So that's the dy dx. Don't forget the 6 minus 2x that we had. And I'm just going to go minus 2y squared. So that would be our expression for dy, or the second derivative, d squared y over dx squared. Now we want to evaluate it at the point 3 comma 1/4. I'm going to go back and refer to this first equation up here. So I'm going to go ahead and plug in 2. Y is 1/4. dy dx is from part A is 0. And then I get 6 minus 2 times 3. Now this entire piece is just going to be 0. Minus, and then I have 2 times y squared. 1/4 squared is 1/16. Double that gives me 1/8, 2/16 if you will. And so we get d squared y over dx squared at the point 3 comma 1/4 is equal to negative 1/8. Part C, find y equals f of x by solving the differential equation with the initial condition f of 3 is 1/4. So we're going to go ahead, we're going to divide by y squared, both sides, and multiply by dx. And that will eliminate the y squared from the right side. That'll eliminate the dx from the left side. In one step, I'm going to go ahead, well, let me go ahead and write it as 1 over y squared times dy equals 6 minus 2x times dx. We then go to integrate. Now, a lot of students make the mistake here of saying that the integral of 1 over something is just the ln. The problem is, because of the chain rule aspect of it, if I'm going to use this as what I'm taking the derivative, the integral of 1 over u, then I need to have that derivative elsewhere, which means I would need a 2y somewhere in this expression, which is not there. The 2, we could balance with a 1/2 up front. We cannot balance that y. So we cannot integrate this as a ln. So the first thing we need to do is, and we've done this before, is to rewrite that as y to the negative 2 dy equals the integral of 6 minus 2x dx. Now we can use the power rule. I get y to the negative 1 over negative 1 equals 6x minus x squared plus c. Let's clean this up a little bit. I'm going to write that as negative 1 over y equals 6x minus x squared plus c. All right, up here, I'm going to take a look at that at the 0.3 comma 1/4. So I get negative 1 over 1/4 equals 6 times 3 minus 3 squared plus c. Again, when I look at this expression 1 over anything, that we could also read as the reciprocal of. So this 1 over 4, I could read as the reciprocal of the reciprocal of 4. Work that out, it does become negative 4. 18 minus 9 plus c. 18 minus 9 is 9. Subtract 9 from both sides, and I get that c is negative 13. So we now have negative 1 over y equals 6x minus x squared minus 13. Let's go ahead and just negate everything. That is, multiply through by negative 1. I get 1 over y equals negative 6x plus x squared plus 13. And I'm going to go ahead and just tuck that minus 6x inside. Now, however you want to handle this is up to you. I just prefer to think of this as this entire right side is over 1. So we are now going to flip or reciprocate both sides. And I get y is equal to 1 over x squared plus 6x plus 13. Now, we are not asked to find the domain. If we were asked to find the domain, we would have to solve x squared minus 6x plus 13 is equal to 0, which is going to require the quadratic formula, come up with a couple of very nasty values for x. We would then have to understand that those values would divide the number line, all real numbers, into several sections, and then find that section that contains the x value of 3 and the y coordinate of 1/4. But again, we're not asked to do that here, so we are good leaving it there. All right, I'll do the number 11 in the next video.